Hello friends, in today's CAD CAM lecture we'll talk about homogeneous transformations. In today's CAD CAM talk about homogeneous transformations. Already we have seen what are 2D transformations and different types. We have solved few problems related. Now what is homogeneous transformation? How does it help? Now we'll try to implement homogeneous transformations for few cases. The reason behind this particular transformation is this will help you if you talk about the advantages of homogeneous transformations. It will help you, for example, first point, to translation can be captured in matrix multiplication format. Earlier we have seen the equation of translation is going to be something P prime is equal to P plus T. This is the equation. Whereas in case of scaling it is P multiplied S, in case of rotation P multiplied by R P prime. These are all three we have seen, we have solved three problems also. But when I said when we do multiple tasks in a single attempt, that is not possible if the translation is in addition format. Now this addition can be avoided with the help of homogeneous coordinate system or homogeneous transformations. The one advantage is, if I talk about advantages, the first one is we can capture or we can translation can be captured. This particular translation can be captured in matrix format, matrix multiplication format, in simple word. And again, one more important advantage is uniform scaling can be performed. That is also possible. And the most important one is we can combine the transformations, that is also possible. And last but not least, points at an infinite distance, infinite distance can be captured easily. For example, for the last point, we'll try to justify out of this graphic window. If the point is somewhere, if you keep on pan the window or if you keep on scroll the window, it is going to be infinity. It never end up. So under that particular infinity window, there is a point existing, means that can be captured easily. For example, if this is your screen, you can keep on scroll your screen. If this is your screen, if you keep on scroll, you keep on get your screen. So the point is somewhere at an infinity distance which is not exactly on the screen, that can't be visualized, that can be captured easily with the help of homogeneous coordinate system. And one more thing is combined transformation, in sense intermediate calculations can be avoided. Intermediate calculations can be easily avoided just with the introduction of homogeneous coordinates in the transformations. One more is uniform scaling can be performed. Now whenever you talk about homogeneous transformations, now the 2D matrix is going to be 3 by 3 matrix. That is the reason we can make this scaling. I'll try to justify each and every bit when I briefly talk about homogeneous transformations. Now for example, in case of homogeneous coordinates, a point, for example, let us take a single point, can be a 2D point is represented something like this, x comma y, and a 3D point is represented x, y and z. We know from our basics, this is how we will represent a 2D point, nothing but 2-dimensional point and a 3-dimensional point. Now same 2-dimensional point in case of homogeneous coordinates can be represented in this format, x, y, 1, and in 3D it is represented something like this, x, y, z and 1. This is the only difference, means we are trying to add one more component over here, nothing but in case of matrix we are trying to add one more row and one more column. Simple. Let us write the same translation, rotation and scaling in matrix format. Let us take first one as translation. Now we know from the basic equation P prime is equal to P plus T. This is the equation we have written, evaluated. Now the same equation can be written in this format, P prime nothing but x prime y prime. No, similarly that can be written in this. One is the term introduced in homogeneous coordinate, x, y, 1, which is an old point or an existing point followed by the matrix of translation. The matrix of translation is written in this form, 1 0 1 0 tx ty 1. Tx ty. Now it all depends on the value given to tx ty such that the point will changes its position. If you want to move a point from one point to the other, that can be changed. Now this translation can be captured. I can justify this now. This translation can be captured in matrix multiplication format. Here I am not adding it. Here also I am trying to multiply it. This xy1 multiplied by 1 0 1 0 tx ty1. This is also multiplication. Now this is a 3 by 3 matrix. 3 by 3. We are adding one row and one column to the existing 2D matrix. Okay. Now again, if you multiply these two, you are going to, as the way we got in simple 2D transformations. Okay. X multiplied by 1. X plus tx y terms. If you multiply, this becomes 0. Y plus ty. Okay. Followed by, you will get 1 if you multiply these two. Okay, ultimately you are achieving the same result again. Achieving the same result means x prime. What is x prime there? What we have seen, x prime is equal to x plus tx, y prime is equal to y plus ty. So this particular one is not affecting anywhere the complete matrix. So it doesn't affect the matrix. Only thing is, this will help you to make the matrix in the form of matrix multiplication. Okay. Now the same equation I'll rewrite. X prime is equal to x plus tx, y prime is equal to y plus, same equation we got. So the answer not going to change, or the position not going to change, whether you take only xy as your point or only xy1 as your point. Ultimately here the aim is to speed up the process. Just because of multiplication we are speeding up the process. Nowhere we are coming across addition. Okay, that is the first point. We have justified this now. Now second point, I said uniform scaling is possible. That's also we'll try to justify. Okay, let us consider second one as rotation. Okay, now for this rotation, again the matrix is written in this format. R is equal to, it is a 3 by 3 matrix, as I said. Cos theta, I'll write it as C theta, sin theta, S theta, 0, minus sin theta, cos theta, 0, 1. Here again we are trying to add one row, one column. That's it, nothing else. It is again a 3 by 3 matrix, simple 3 by 3 matrix. Now the same thing can be expressed in this format, like x prime, y prime 1, which is p prime, is equal to x, y 1, which is p, multiplied by this matrix cos theta, sin theta 0, minus sin theta, cos theta 0, 1. If you multiply these two, you are again going to get the same product. That is equal to simply x cos theta minus y sin theta. Okay. Similarly, x sin theta plus y cos theta, comma 1. 1 will remain same. 1 multiplied by 0 plus multiplied by 1. You will get 1. Okay. Now out of these terms, again you could see the common things. X cos theta is nothing but x prime. Okay. X sin theta, nothing but y prime. If this is the case, x prime, y prime. So if this is the case, the same can be written. We have justified now. Easily you can justify this too. Now x prime, y prime 1 is equal to p prime. This is going to be a p. Sorry, this is your p. Simple p. Okay. Now x prime is equal to x cos theta. Y prime is equal to y cos theta. And 1. This no way it is going to affect the complete matrix. Okay. This is your final matrix that you need to remember. Fine. Now again the third one, if you take the third one, is all about scaling. Now scaling matter, again similar to this particular format, I'll try to write it as S is equal to Sx 0, Sy 0 and 0 1. Okay. Now as I said, if you change the value of Sx, Sy, maybe Sx is equal to 2, Sy is equal to 4, the entity size going to be non-uniform. Size of the entity going to be non-uniform. Okay. Similarly, if you try to give same number, it is going to be uniform. Okay. If you want to make the entity uniform, no need to change Sx, Sy. You can change with a uniform scaling can be done by changing a single entity. This particular entity, if you change the number here, the entity size going to be uniform. A single number can make this uniform. That is a flexibility. Okay. Now same equation, in the equation form, that can be written in this format. X prime, y prime 1 is equal to xy 1, that is again multiplied by the same matrix Sx 0, Sy 0 and 0 1. Okay. Finally you are going to get S multiplied by Sx, comma I multiplied by Sy, comma 1. Okay. No way this 1 going to affect ultimately. Okay. So here we have justified all the statement with respect to the equations. Okay. Now with the introduction of this homogeneous coordinate system or transformations, intermediate calculations can be avoided. What is that? I'll try to make a point here. Intermediate calculations can be avoided. That is possible. Okay, now again I have mentioned few more points. Combine sequence, we can combine the sequence of transformations. Okay, combine sequences can be combined easily. Okay, now with this we can speed up the process completely. Process can be speeded up. Now only thing what we need to know is we need to remember this particular translation matrix for homogeneous, rotation matrix for homogeneous, and scaling matrix for homogeneous. Similarly, we have for reflection nothing but mirroring also, which is very much simple. Again, we will try to discuss all of them in the upcoming lectures. This is all for now. Thank you.